Hello friends, today we're gonna study about hydraulics and we will try to solve every hydraulics law step by step, one by one. So first we will start by Pascal's law. Okay, we'll start by proving Pascal's law. So before starting Pascal's law, let me just define pressure because this is a very important terminology in hydraulics. What is pressure? We have all studied that force by area is pressure since our childhood. But what type of force is this? If I ask you what is stress, your answer will again be force by area. Can you tell me what the force here and the force here means? Are these two forces similar or are they different? So basically the force that we study in stress is the internal resisting force. Internal resisting force, and the force that we are talking here in the pressure is compressive type of force. It's normal and it's external force. So whenever you define pressure, don't just say force by area. Try to say that pressure is defined as the external normal compressive force per unit area. That's a very, very important definition. All right. Now tell me, this is a surface, any surface, above which there's water. This is any surface above which there is water, and let's say the height of this is h1, and I put here points like point A, point B, point C. Can you tell me which point will feel more pressure? A is likely to feel more pressure because all this particle is going to put pressure in this. B is also going to feel pressure, but the pressure is lesser than A and more than C, because for B it's only this area that will apply pressure, and for C it's even small because it's only this area that's going to apply pressure to C. That means on going downward, what will we observe? That A has more pressure relative to B. So on going downward, pressure increases. On going up, relatively pressure decreases. So this is like the basic theory. Or in other sense, if you have heard that when you climb Mount Everest, they say that it's very difficult to breathe because oxygen is so less, so you need to carry oxygen cylinder. Why do it feel very difficult to breathe on climbing the mountains? Because as you increase in altitude, as you increase in height, the pressure decreases. And now we're going to see that based on another very important thing that is called the local and standard atmospheric pressure. Based on local and standard atmospheric pressure. So what is local and standard atmospheric pressure? So local and standard atmospheric pressure is the pressure at exerted, I can write it, exerted by environmental factors, or it was to say pressure exerted by environmental mass, under, because we're talking about local pressure, so under local conditions, right? That means this kind of pressure under local conditions says that the pressure can vary with place. That is local pressure. What is standard pressure? Standard pressure It's also the pressure exerted by the environmental mass under a standard condition. What is that standard condition? Standard condition lies at bed level of ocean. The air that floats at the bed level of ocean at 15 degrees Celsius is our standard pressure. And what is the standard atmospheric pressure? 760 mm of Sg. What can we write this? 1.0135 into 10 to the power 5 Pascal, or just 1.01325 bar. This formula, this is a standard formula, the standard. Now we will talk about gauge pressure and absolute pressure. Okay, so to understand this, let's make a graph. So let me make a graph, something like this. This is a state of absolute zero. Okay, state of absolute zero. Here we will write pressure. We will show the pressure in kilopascal. Let's say currently I am in a room, right? This room that I'm making this video. The pressure in this room is, let's assume I'll call it from like 0 to, this pressure diagram. I'll call it right now, I'm in 100 kPa. Now if I make a line like this line is the 100 kilopascal line. And this pressure, I will call it local atmospheric pressure. Write it as P ATM L. Okay. Now let's take a pressure over here, 130 kilopascal. Okay, I'll take this pressure. If I measure this pressure 130 kilopascal, if I measure this 130 kilopascal with respect to local atmospheric pressure, this, that is known as, okay, let us suppose somewhere over here at this point A, we have 130 kilopascal, or any point over this line is 130 kilopascal. Now if I measure pressure at A, this pressure, because I measured with respect to local atmospheric pressure, this is called the gauge pressure. How much is this? With respect, it's not 130, right? Is it 130? No, it is what? 130 minus 100, 30 kilopascal. And since it is above local atmospheric pressure line, it's positive gauge pressure. Okay. Now what if I measure the pressure at the same point A, but this time with respect to the absolute zero, this will give me pressure that I call it absolute pressure at A. What is that? From 0 to this is 130 kilopascal. So this is my absolute pressure at A. Okay. Now, my friend, let me take another pressure over here. So if I make a line like this, now tell me at a point B, if I measure pressure from this local atmospheric pressure, what is the pressure of B? This is called gauge pressure. We have known so far because I'm measuring it with respect to local atmospheric pressure, and the pressure will be, because this is 100 and this is 60, how much is this going to be? 40 kilopascal. But this time it's negative. Why? Because it's below atmospheric pressure. And if I measure the pressure of B with respect to gauge per absolute zero, this is PB absolute pressure. That is nothing but 60 kilopascal. And with respect to absolute zero, if I measure till this local atmospheric pressure, it is simply atmospheric pressure 100 kilopascal. I can write local atmospheric pressure, local atmospheric 100 kilopascal. I can write Yes. So my dear friends, what have we learned? Like, let's just talk about point A for now. The absolute pressure of point A equivalent to this pressure, this PA gauge pressure till here, right? So PA gauge pressure plus this total is absolute, right? So which comes from the addition of this gauge pressure, and from here to here is local atmospheric pressure. So local atmospheric pressure. From here I get gauge pressure is equals to absolute pressure minus local atmospheric pressure. Now this gauge pressure can be positive or negative. When is this pressure positive? This pressure is positive if it lies below, positive if it lies above local atmospheric pressure, and negative if it lies below local atmospheric pressure. So that is also what we called. And remember the negative gauge pressure, okay? Negative gauge pressure is also called vacuum or suction pressure. Vacuum or suction pressure. Okay. So in this way, if I have to define absolute pressure, I will define it as the pressure, or it is the absolute pressure is actually the the actual pressure. For example, if I say absolute pressure of A, then it is 130 kilopascal, right? Absolute pressure at A is 130 kilopascal because I measure it from absolute zero. So this is the actual pressure at a given location with reference to absolute zero, and this value, this absolute pressure, is always positive. Gauge pressure is measured with respect to local atmospheric pressure, and it can be positive or negative. So this is the thing that you have to understand. So when is it negative and when it is positive? If I ask you, then you have to know that gauge pressure is positive when absolute pressure is greater than local atmospheric pressure, and it's negative when absolute pressure is less than local atmospheric pressure. You can put the value over here and also get the value. If it comes minus, it's negative, it's plus, it's positive. Correct? That's it about absolute and gauge pressure. After knowing this much, now we will talk about what I was about to discuss, Pascal's law.